So today we'll be training and teaching you how on building this Hindi translation app, web app. So this is an entirely voice-based web app. So by voice-based I mean the inputs and the outputs both are in voice. And they will be done in Indian languages. I mean the translation will be done in Indian languages. So first let me demonstrate the working. So let's say my source language is in Tamil. And my target language is, let's say, out of all these languages, I choose Hindi. And I say something like, Vanakkam.
Namaste. Namaste.
So, like I said, my input voice that I gave was Vanakkam, and it got translated to Hindi as Namaste, and it then got converted into speech, and then displayed as like this.
Namaste.
This is the basic prototype that we are planning to teach you guys build by the end of this session. So, Indian translation, as you know, is integration of various models, and on the working of the models and basic outline of how it works will be given by our team. While if you have any doubts, kindly raise your hands and we'll come and address you. And if you have any doubts, the team members will be able to come and address you. So, if team members could show your hands, they could see. Just show yourselves. And also others who are outside, they will also come and help you out. So if any clarifications, you can come and clarify with us. Okay, so
Check it out.
So kindly open this GitHub link. Let's get started with the workshop. So I hope you all have VS Code and Python installed in your laptops as well.
Can you please read out the GitHub?
Yeah, it's HTTPS colon / github.com / k-m-ifan ifan ifan k-m-ifan irfan 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 / voice 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 irfan / voice _ translation _ workshop. The zip file, extract the files and open it in the terminal. Linux. I am working on a Linux system here. So extraction process and opening it in terminal is almost like the Windows also. So you can extract it here or any folder that you desire, and you can open the folder and you can open it in the terminal. Yes, sir.
Give this comment.
And repeat again, you can open it, click right click, go down and open it in terminal. Okay. So From there, I request you to open VS Code. To open in VS Code, all you have to do is type code, C-O-D-E code, space, dot, enter. Once you are inside the VS Code, you will find a template, a Python template file. So now I would like to hand over the session to Grishma, where she will be explaining again the outline of entire models and also how APIs and requests work.
Good morning, models. My name is Grishma. I will be just introducing you guys to what is an application program interface (API) and how we are going to integrate the different models, which was explained by our professors, into the code system. So in that application example that you saw that we were actually taking a speech input and converting it into any particular language and producing the output in that language. It was a translator app. So now we'll show step by step how that is happening. So first of all, we have the input voice in this particular languages, which is fed into the automatic speech recognition, which was explained by Hema ma'am and Umesh sir. And after that, there is a machine translation model, which was explained by Nitesh sir. And that is, again, the output of this machine translation, which is a text, is fed into the text-to-speech model, which will be creating the speech in that language. So, for interfacing all these three models, we will be using something called application program interface. These models are very complicated. There is like a whole step of it, like how the sound is getting processed, how the language is getting processed, all the steps comes in. So we can't just host it entirely. Like if you have a mobile phone, we can't have the entire code running in your mobile phone, can we? So we will have a powerful system running in the backend, which will be running all these codes. And we will be sending whatever data that we need to that and expecting it to send us the data that we need to display. So that is what application programming interface does. So a simple analogy is that if I am sending a letter to someone, so I need a postman to come and take the letter and take it to that person. So that is what this is API does. So this is the postman is basically the API. And when I am sending the letter to someone, the second thing I need is the address where I will be sending it to. That will be given by the address of that endpoint. So in this case, the person who's sending it will be the client, that is your mobile phone, and the server will be the person who's accepting it. That is the main code which will be hosted in the big systems. And the postman is going to take the data there. So when you are sending a data or when you are sending a letter, you need to make sure that the person who's receiving it also is able to understand the language. So you can like send it in one language and expect the other person to understand in Hindi. So it's like, for that we need to follow a constant. So if I am sending it the letter in English, the person receiving it should also know English. So that is why we choose a format known as the JSON format. JSON will have something like a key, that is a name, and a value. What is the name? So what a simple example will be, in the phone you will be selling something like a name. My name, key value name is there and the value is John Doe. So when I send it there, the server will go there, process, okay, the name that I need is John Doe, ask the database to maybe give the ID and account number of the name and of the value associated with John Doe. And this will be all done in the backend. So the mobile need not go to the database, find the value and all, and that will be returned back to the mobile phone. Only the value, the ID and the account will be returned back. So that is basically the function of API. So regarding automatic speech recognition, I invite Gada to give a speech.
Thank you. So now automatic speech recognition. Here Professor Umesh was here to speak about automatic speech recognition. So basically what we are doing is that there will be input audio, and from there it will be going to pre-processing, where audio will be captured and noise reduction and resampling will be done. Pre-processing is actually like if you have an audio, there will be pauses and everything. So we'll be removing all these pauses and all those things, and we'll be giving it to the next step, which is feature extraction. In feature extraction, we'll be taking only the features of the audio, which is given to the deep learning model, which is already trained, and from the deep learning model, we'll be getting the output text. So now we'll be doing the hands-on for the ASR, and that will be done by Sandeep.
Yeah, I'll keep a postman.
Yeah, postman. Okay.
So Postman is a platform where you can check and test your application that you hosted. So if you have a API format, you can just specify it here and then send requests and you will get response and just check whether the
So,
system is working.
this is actually the ASR's, the automatic speech recognition's postman API. So it is just an application that will be sending the request for you, like sending the letter to them. So in this case, for ASR, the details that we are giving is, one is the audio file that we have. We have recorded an audio file of a person speaking, right? So that will be sent to the server. And also then BTT is like the real timestamp of the audio, where is it like, when you speak a sentence, there will be pauses and there will be words. So this timestamp will give where the words are. And if you give it as true, then the server will return where all the words are, the timestamp of that, in that audio. And the language in which you want it to be. It's like if the speech is in English, you need to specify that the person is speaking in English. Yeah, and the response that you will be getting once you hit the send button here, giving the address, like where the server is hosted, you will be getting a response giving that the status is success and the time taken for that whole transcription, and also the transcript which is there in that speech. So now we have given a text with the audio file having a word only, and now the transcript will give us the only response. So this is what you will be coding in Python. You don't need this Postman application, you will be coding the same in Python. So for that I will call Sandeep.
Okay, I hope that you have installed the requirements file. If you haven't, we have to install the requirements file first. Sorry.
Let him load the.
Oh, okay, sorry. Is the screen visible at the back? Yes? Size? This is okay. For the people at the back, is it visible? So this size is okay? Little more. Okay. I think almost all of you have downloaded the Git repository. After in the Git repository, you will have a requirements file. So everyone has to install the requirements file. So if you go to the requirements.exe, you will have Flask, Socket.io, which is needed to run this application. So the first thing that you need to do is open your terminal and you can do a simple pip install -r requirements.exe, which will install all the requirements file needed to run this program. So for us, the requirements file are already satisfied. For you guys, the installation will take place one by one. Okay. So the first thing, I think people have completed this step. I'm assuming that people have completed this step. So the next thing is we need an endpoint to give a request, right? Earlier you have seen Grishma, who has demonstrated sending an API request to the server and getting the transcript, right? So here we need to define our ASR endpoint. So the ASR endpoint will be, yeah, it is visible in this side slide. So we have to type that endpoint. So this is the IP address where you will be hitting your request in order to get a response. So the ASR endpoint is https://projects.respar.iatm.ac.in:8009/ASR. So this will be our ASR endpoint. Okay, I assume everyone has completed till this much. Any doubts? This is the endpoint at which you will be sending your request. Okay, if you go down in the template.py, we have a definition for speech to text. It's a function, we need to write that. So basically what this speech to text function does is that it takes input language and input file, which is a binary file here, and it sends that request to the endpoint with a required payload, and we get a response from the endpoint. In the speech to text function, this is for calling, taking input language and input file, which is a binary file here. We'll take these two parameters and we'll be sending this as a request to the API endpoint. So I'll just do a print here, just the ASR function called. So whenever you're calling this function, it will show it in the terminal that the ASR function is called. The next thing is, okay, Grishma, this slide. So for those who did not get the endpoint, this is the endpoint, http://project.respar.iatm.ac.in:8009/ASR. Okay, so this will be, as you can see, the endpoints are shown here. So when we send a request, request to the endpoint, we have to send it in a specified format so that the server can read it and give us a response. So we have to send a page. Now next, line number 127. We have to send an audio file to the server, right? So for that I am declaring a variable files, which is an array which takes the key file and it contains 3 tuples, which is first the name of the file, that is input mp3. Next is the parameter, that is the binary file that you have passed to speech to text, so that is the input file. And what type of file it is, like it's a binary file, so we have to write application slash octet string. I am defining headers, which is this is for sending to the API request. Here the header is none, so this headers is equal to open close bracket, curly bracket, which means that no header is specified. While you do machine translation and text to speech, you will see that the headers are not empty. It will contain some application type, whether it's a JSON or anything else. So in our case, the ASR endpoint accepts no header. So we are just putting as that. So in line 129, I am defining a variable response, which is equal to request.request. So request is a library that is used to send requests to the HTTP endpoint to get the data. So in line 129, response is equal to requests dot request. This is the format. And what type of request I am giving, whether it's a post request or get request. Here it is a post request. So POST capital in colons. And where I am sending this request, post request, I am sending it to an endpoint, right? So I will define ASR endpoint, which we have already given in line 25. We have defined that in line 25. The ASR endpoint is HTTP project.spark.ap. We have defined that endpoint, and we are just putting that endpoint here. And headers is empty, so headers itself. Headers equal to headers. And what are we sending to this endpoint? ASR endpoint is sending a data, which is the payload. And also we are sending the files also, so the files is equal to files. So in one line 129, response equal to request.request, open bracket in colons post POST, comma, the endpoint, which is ASR endpoint, which we have defined, comma, headers will be headers, which is empty in our case, and the data that you're sending is the payload, if we have defined, and the files is the files that you have defined. So interested people can check the documentation for request.request. So request.request is sending a post request to the ASR endpoint with whatever data that we have given, and it will give us a response to it. So that response is stored in a variable called response that is defined here, and what we will do is we will return this. Now we need to call this function in line number 68. So in line number 68, what I will be doing is I have written the speech to text function. I'll be calling it here. So in line number 68, STT is equal to speech to text. Here my input language I am getting from the web application. The user is inputting, and the audio data, which is a base 64-bit string. So the function, the speech to text function is returning the response in a text format, right? So what we will be doing is we want that in a JSON format. So before calling speech to text, what I'll do is I'll do JSON.loads so that I will get it in a JSON format. And what you can see in this slide is that we are only interested in the transcript part of the response. We are not interested in any other things such as status, time taken, or VTT. We only want the transcript. So what I will do is write around it. So I will be taking only the transcript. So in square brackets I write transcript. So in line 68 I am repeating std equal to json.loads open bracket, we are calling the speech to text function there and giving input language and audio data, closing the brackets, and in square brackets we are only interested in the transcript part. So this is all from one side. So next, Ron will be explaining the machine translation part of this. So this time we'll be going a little more fast in the interest of time.
They can't.
Okay, I guess everyone has done that ASR function and integration. Now we'll be going in depth machine translation. So it's in the same way that we have done the ASR. Like we'll be, let's say we'll be printing like I'm just printing one statement like machine translation is called. Okay, just to get like if the function is called or not. Then in the same manner as ASR, we are defining our payload. Here our payload is like payload equals to, in the curly brackets, source language in source language, we are defining the source language as C language, then target language, TGT language, and the transcript part. That is transcript. So the payload is defined as source language, target language, and the transcript part. Then we'll be taking this. This is the payload that we are giving it to the server, and we are getting the response. That is response equals to request dot request in the parenthesis bracket we will be writing empty endpoint that we have defined, that we will be defining upstairs in the above code, and the data that will be our equals to payload. This is, we are giving it as a endpoint. And we'll be returning the response. But in the response, we just want the empty out part, so we'll be writing empty out. I hope everyone is in sync, or You can ask the volunteers to. Yeah.
Anyone did not complete that payloads one?
The payload format is shown here itself. You can see that instead of the language only, we are giving payload.
Now we will be going in the starting where we have defined ASR endpoints. We will be defining our empty endpoints also. That will be same as the previous one. Just here, the endpoint will be the same, just after 8009, after backslash, we'll be changing the ASR to translate. After this, initially we have called ASR function as STD. In that, when we are calling ASR function, we return STD function. Okay. So now we'll be calling our machine translation function as translation. Right, line number 84. You can see line number 84. Here translation equals to empty input language comma target language. In machine translation, the function we have written requires 3 inputs. First is input language, that's our text is, the output language that you want to convert it, and the text we want to convert. So the text that we are getting from ASR, that will be giving it to machine translation, that is STD. Here in line 68 you have defined one variable called STD, that is our ASR output as text, that will be giving here as our input. Now furthermore, ETS will be explained by Irfan, and if you have any doubts you can raise, volunteers will come to you.
Constraints. We have one more module.
So looking into the time constraint that we have, we will speed up a little bit, and also in the end we will provide the solution for it so that you can go back home and check it out or experiment on it. So yeah. So we'll start by, we already finished ASR function, machine translation function, and started using it in these 2 lines. Okay. So from machine translation you will get a text which is in your output language. So that text has to be converted to audio so that it plays out. Okay. So we will define TTS function now. So we can go to function definition TTS in line 149. So as usual we will print the line that says TTS called. Okay. So print /n is for new line so that everything is not written up, and then TTS function call. So that later when you're debugging, you'll know that the request function is called. Okay. So just like all the APIs, you have to define a payload that says what that gives your input to the endpoint, and so that you'll get the output accordingly. So payload will be equal to we need to give two things. One is the input. Okay. So that will be in string. The key value of the input is input, and the text that you have to give, the text is coming from here. Okay, so same variable. Similarly, we have to give gender, so gender, and that is coming from again here. Okay. And finally, you have to mention your language ID. So any language ID will be coming from the function itself. So lang, key for language ID is lang. Okay. Sorry. And you have to pass this language. And one last key that we will be passing is the alpha value. Okay. Alpha value is used to determine the speed of speech synthesis. Sure. So the alpha value is just it's between 0 to 1, maybe more than that. So this changes the speed of the speech synthesis. So if you want to play with that to make it speed or slow, you can do it. So the ideal speed that we choose is 0.95. Okay. So once your payload is ready, you will give headers similar to the last one. So its content type will be JSON. Okay.
The word is cat.
Yeah.
Okay.
Yeah, that's fine. So once we have defined headers also, we can directly go for the response. Okay. So response variable is requests, not request. And again we are again we are posting the request to the TTS endpoint, and giving headers which we have already defined, and data that goes as payload. Okay. And finally, we have to convert it into a JSON format. So that's how the backend expects it. So JSON at the end. So we are done with function definition, and in the end we can just return the response. Okay. Once we are done with function definition, we can go back up. Once we are done defining the function, we can go up and call the final module that completes the entire workshop. I mean the voice-to-voice translation application. So you can just call it. You can copy this file. It is already given as example, and you can put it here. So remove this comment. Once you get the output, again, just like you mentioned in the payload, we are interested in the audio part. This is tedious. So we are interested in the audio part, not the remaining part of it. So we have to mention that we want to extract audio from the response. So you give that key for audio here. So in the end, TTS will be the output. I mean, you will get the encoded string. Okay. So that encoded string you have to decode and put it into an audio file so that you can hear it, or you can send it to the front end. So we decode The base64 encoded string.
Event also.
There.
Huh?
There.
Oh yeah, it's there already. So it's part of the template. So let's stop. So decoded string is there, and then it converts it to audio stream so that you don't have to save it on your hard disk. So temporarily it will be saved in this variable, and you can directly send that using the send file function of Classic. Okay, this function. This will send it to your front end, and then everything else will be taken care of by the front end. So there is a last module in the front end where you can play the audio. So yeah, we forgot to mention the endpoint here. So endpoint is similar until this point, and you can change the last one to tickets. Okay. So if we did everything right, hopefully this should work. If this is not working, we will copy the solution because of the time constraint. So let's try. You can just open your terminal and either type Python template.py. It says Python is not there, so if anybody is experiencing this problem, you can just type Python. Yeah, it says it started. That's a good sign. And since we have mentioned the port and the host, which is localhost here, so you can open your browser, any browser, and just type https://localhost port 5000. That's it. It should work. So this is the front end UI, which has been already provided using the back end. Now that we finished the back end, hopefully this should work. If it doesn't work, we have already uploaded the solution just now. So just to complete this workshop, we can copy that solution because it doesn't have any. We might have done any typing mistake or something that might cause error in it. So we just select source language English, target language, let's say Hindi. Let us try to ask something and see if there is any problem. So that's fine. And here you have hello, how are you? And see if it is coming something. So it's not. So okay, let's try. Hello, how are you? It says transcript here. Okay, we have done some typo here, so we can. Okay, so. Because of the time constraint, we will not be going to debug all these errors. So we have a completed solution uploaded in the same GitHub link. You can refresh that link, and there will be one file called solution.py. And you can copy that and just put it inside your template. Like remove everything. This is exactly what we did. What we did in this hands-on session, but without any typo or error. So you can debug that later. This is the complete working code for what we have demonstrated right now. We'll try to run it now. Let's see how it works. So yeah, it started. We'll try to reload it. Hello, how are you? Yes, sir. Hello, how are you? They're not good, I guess. it's not working.
Have you
So,
saved it?
Yeah. Let's see. So let's see if ASR is hello. Okay, so it's working.
नमस्कार का प्रयोग अभिवादन या टेलीफोन कॉल के उत्तर में
So this is the one that we hosted with exact backend. So we'll test with it. There is some error in the code, so that it shows transcript errors. ASR part is not done well. I mean, the backend we might have done some spelling mistake. So we can go back home and use the solution file that we have provided, and you can run it. So just to demonstrate, this is exactly what we have hosted, and you can test it out with in this link. So English, Hindi, output, any language you can give from the list of these languages. So if I can just ask, how can I go to Chennai from here? So it says,
இங்கிருந்து நான் எப்படி சென்னைக்கு செல்ல முடியும்
is it audible?
இங்கிருந்து நான் எப்படி சென்னைக்கு செல்ல முடியும்
Just like any output I can give with this option. If anybody knows Marathi and Tamil or Telugu, you can check it out. Okay?
So anyway, we have the solution uploaded.
You can go right to the website and again try to installing
Some
it.
typo.
So we'll wind up. Anything else? Yeah. So where is lunch provided?
Yeah, we have lunch.
You can go there and have your lunch. The time constraint was due to the lunch timing, so sorry for that.
But anyway, you can bring it back. It is already uploaded. The file is uploaded. The same thing.
The same